Calculating permutations. Example: Caitlin has 3 textbooks for 3 of her courses, namely a science book, a literature book, and a political science book. She wonders how many different ways she can place them in some order on her bookshelf. She calls the science book S, the literature book L, and the political science book P. Then by trial and error, she finds these 6 arrangements: SLP, SPL, PSL, PLS, LPS, LSP. If she had 12 books, she knows the problem might be too difficult to find out how many arrangements there are by trial and error, and wonders if there is a formula to tell her how many arrangements there might be. Definition: a permutation of a non-empty set S is an arrangement or ordered list of elements of S. Definition: an ordered list of R elements of an n-element set S is called an R permutation of the elements of S. The number of R permutations of an n-element set is denoted by what you see highlighted in yellow, P of n, R. Theorem: the number of R permutations of an n-element set where R is a number between and including 1 up to n is P of n, R equals n factorial over the quantity n minus R factorial. A reminder, if you're unfamiliar with what n factorial means, n factorial is 1 if n equals 0, and it's n times the next smaller number, n minus 1, times the next smaller number, n minus 2, and so on until you get all the way down to 2 times 1. And that's for all numbers n greater than or equal to 1. So n factorial is only defined for non-negative numbers. Example: find the permutations of 3 things taken 3 at a time. So n is 3 and R is 3. In other words, we want to find the number of arrangements of the 3 items, such as 3 books in our first example. Solution: the permutation of 3 things taken 3 at a time is n factorial, that's 3 factorial, over quantity 3 minus 3 factorial, both n and R are 3, and that equals 3 factorial over 0 factorial, and by the definition of factorial, 3 factorial means 3 times 2 times 1, 0 factorial equals 1, so we have 3 times 2 is 6 times 1 over 1 is 6, the same answer we got by trial and error. Example: find the permutation of 20 things taken 5 at a time. N is 20, R is 5. So we have a collection of some 20 objects. We want to grab 5 and see how many different ways we can arrange them in a line or a list. Solution: the permutation of 20 things taken 5 at a time substituted into the formula is 20 factorial over 20 minus 5 factorial, so that's 20 factorial over 15 factorial, and writing that out, 20 factorial means 20 times 19 times 18 times 17 times 16 times 15 times 14, and keep on going on in the same pattern until we get down to 2 times 1. Over 15 factorial is 15 times 14, and so on, all the way down to 2 times 1. So we have some repetition of factors in the numerator and the denominator that we can cancel out. All of the ones beginning at 15, 14, 13, all the way down to 1. And that leaves us with just 20 times 19 times 18 times 17 times 16. And you're likely to overflow your calculator if you don't cancel first. But I can use the calculator to multiply the remaining 5 numbers, and we see that there are 1,860,480 arrangements of 5 items chosen out of 20, placed in some order. Each order is a different count. Example. Let's find the permutation of 20 things taken 5 at a time using the TI-84 plus calculator. Solution. The permutation function is built into the TI-84 plus calculator. The following key presses find the desired permutation. And I will show you that on the calculator. We first press 20, then Math. There are several menus here. You see the little circle 3 by the right arrow, which means to arrow over 1, 2, 3 times. This is to the probability menu. And then arrow down once, and there's our permutation function, written a little differently than we do with a P of n comma r. But it means permutation, and the n we already typed. We press enter to select NPR, and then press the R, and you see we get the same result as we got by hand. Please use your TI-84 calculator for finding permutations. Calculating combinations. Permutations dealt with items that we want to place in order. Combinations deal with selection of items and we don't care about the order. There's no order involved. So, for example, a discrete mathematics class of 25 wishes to have an end of semester party. A committee of 5 people will be chosen to organize the party and purchase the supplies. How many different committees of 5 are possible out of this class of 25? This is a combination problem. Writing out the names of all the class members and using trial and error would be a very difficult task. So is there a formula? Well, of course there is, but we'll start with a definition. Definition. Let S be an n-element set, and R-element subset of S, where R is between and including 0 and n, is called an R combination of S. Therefore, the number of R combinations of an n-element set is notated as C of n comma R. An R combination is also referred to as an unordered list of R elements or as an R selection. Theorem. For integers R and n, with R between 0 and n, and including 0 and n, the number of R element subsets of an n element set, also called R combinations or R selections of an n element set, is C of n comma R. Now notice the middle part. This is the other way to write a combination of n things taken r at a time and is generally read n choose r, equals n factorial over r factorial times quantity n minus r factorial. This is very similar to the permutation formula, but there's an extra r factorial factor in the denominator. So let's find the number of combinations of the 25-member class taken 5 at a time. How many committees are possible? Well, we substitute into the formula, and n is 25, r is 5, so we get 25 factorial over 5 factorial times quantity 25 minus 5 factorial, which is, starting in the numerator, 25 times 24 times 23 times 22 times 21 times 20 times 19 times 18, 17, all the way down to 1. Or I can shorten that last part, 20 times 19 times 18, all the way down to 1, to just 20 factorial. And in the denominator, 5 factorial is 5 times 4 times 3 times 2 times 1. And 25 minus 5 factorial is 20 factorial. And I'll leave it that way because now I can cancel out the 20 factorial out of the numerator and denominator. And we can see that 5 goes into 25 5 times. 4 times 3 is 12. And I can cancel the 12 with the 24, leaving a 2 in the numerator. And the factor of 2 can cancel with the 22, leaving an 11 in the numerator. So we have 5 times 2 times 23 times 11 times 21 over 1. And using the calculator, we see that there are 53,130 possible different committees. And a committee is an unordered list. Well, let's find the same value, the combination of 25 things taken 5 at a time, using the TI-84 plus calculator. You probably have guessed by now that a function is built into the calculator to calculate combinations. So here are the key presses and what the main screen looks like. And I'll open up the calculator again, clear it, and show you the key presses. 25, then the math button, right arrow 3, 1, 2, 3, to the probability menu, and this time down arrow 2, and that brings us to combination. We already entered the n first, the 25. Now we hit enter and press the 5 key and enter again, and you see we get the same value that we did using just arithmetic and cancellation to arrive at the answer.